what works in the laboratory doesn't automatically scale into the real world.
Do you have examples of guardrails that play a central role in your solutions?
As soon as an AI starts to make choices on your behalf, you better make sure that those choices fall within acceptable limits.
Was there a moment where you thought, I'm not so sure whether this will ever work?
Many times.
Yes?
To be fair.
Hi, welcome to the Signal podcast, the podcast where we turn complex IT topics into business clarity. My name is Werner Heijstek, I'm your host. Recently we published the AI Boardroom Gap report, where we highlight the gap between AI ambition and operational reality. Today we're going to talk about, with the co-CEO of Samotics, Simon Jagers, about actual operational reality in IT. Welcome.
Thank you.
Maybe for the listeners, can you briefly explain what it is that Samotics does?
Yeah, at Samotics we monitor critical machines for companies operating in predominantly heavy industry. And we do that by analyzing electrical waveforms using AI. And the output to them is insights into the condition, performance and energy efficiency of those critical machines.
And when you say analyze, what do you use to do those analysis? Is that hardware, software?
Well, it's a plug-and-play system that essentially covers the entire stack. So we develop sensors that generate high-frequency electrical data. We then have signal processing and AI algorithms that turn that data into information, which we present in a dashboard. And all of that is then provided, including an expert monitoring service. So humans and machines working together.
The whole package, including a human also.
Yeah.
And do you engineer the whole system in-house?
Yeah. Everything is developed in-house.
Everything is developed in-house. So you have been doing this for about 10 years now?
Yeah.
Can you take us back to 2015? How did this begin?
Well, it began with the insight that there's a lot of data in industry that is not used, certainly not for condition monitoring purposes. Yet the cost of failing equipment is high and rising due to, for instance, the fact that processes are more and more optimized, right? So then if there's an interruption in the process, that also leads to higher cost, typically. And so what we essentially saw is that there is a gap between the requirements of the business and the tools to turn existing data sources into valuable information.
So when you started around 2015, AI wasn't as big as it is today. Yet you make a choice. You made a choice to use it. How did you get to this decision?
The idea was, in my view, elegantly simple. And that is, there's a lot of data. There's a lot of information in that data. If we can extract that information, we can provide value and capture then some of that value for ourselves. Yeah. That's the whole sort of the business idea. Yeah. It was also wrong. I think there is and was a lot of data available, but that doesn't automatically mean that there's a lot of value in it.
No.
And also, even if there's value in it, you have to get access to the data, which is problematic for a startup, because you want to work with the biggest clients. But the biggest clients also don't want to work with a bunch of guys in, at the time, Amsterdam, to give access to the data, sure, right? Even if we gained access to the data, we had to clean it and then find out after a few steps that the data wasn't useful for the purpose for which you wanted to use it. So what we found out indeed is that it was elegantly simple, a bit too simple. But what we did find out is that the problem that we were trying to solve was very real and very valuable to our clients. So we simply had to fix the fact that the data wasn't available.
So how did you go about doing that? So what was the first moment at which you gained some trust in the actual feasibility of the solution?
Well, essentially what we did with us being non-mechanical engineers, we were sort of, I would almost call it free thinkers in the space, right? We weren't burdened by existing ideas about what could work and what wouldn't work. But we did have to rely on common sense. And common sense said that if the problem of machine failure is expensive, then our next idea was, if we cannot use existing data sources, we'll create some of our own data. And historically, that has always been vibration data, right? So if you run a factory, you have on the shop floor, you have hundreds, if not thousands, of machines that are powered by industrial electric motors.
Yeah.
And if anything on that drivetrain fails, it generally starts to vibrate differently. The mechanism is that if you think of a drivetrain, so a motor, a transmission, and a driven load, so motor, gearbox, and a pump, that it can fail in one of two ways. It can fail because of an electrical problem and because of a mechanical problem. If you measure high-frequency electrical data, it intuitively makes sense that you see electrical problems emerging in that system, and that's indeed the case. But what we found, and we thought for a brief moment we were the only ones to find a relationship between the electrical signal and mechanical faults. From a physics perspective, a mechanical fault leads to a vibration, and a vibration shakes the motor a tiny little bit differently, and that leads to a disturbance of the magnetic field and in turn a ripple effect on the sine wave. And so what this meant for us is that we could very accurately detect upcoming faults weeks to months before downtime happens without the need to install a sensor in the field. And because roughly 30 to 40% of critical machines in industry operate in places where it's either physically or economically impossible to install a sensor on that equipment, and because from a business perspective, we for a brief moment thought we were the only ones who knew this, we've sensed, okay, this solves a lot of problems that we've had experience with our previous approaches.
So you're slowly having this journey where you start gaining trust in your solution. In the meantime, you were selling this and managing this. How did you deal with this? Because at some point you might have not been very sure of the accuracy, and so there was a collaboration with Structon, for example. Mm-hmm. How do you manage the trust that you then have yourself with your team in the solution that you're building, with the increased data collection, with the machine learning models on top of that, and the expectations at the client side?
I think it's all about being open. Initially, you're basically selling potential, which means that for our clients, operators, they intuitively sense that if you have like a system that can give them insights into their equipment without installing sensors on that equipment, you solve a real problem, meaning that a lot of their critical equipment simply isn't sensored up because it operates submerged in sewage, or it operates in a blast furnace in the steel industry where sensors would burn, right? So we provided a feasible way to solve that industrial blind spot problem. What I think we did well is that we were always quite open about where we stood from a technology perspective. Doesn't mean we would always meet the expectations that we raised ourselves or that we voiced ourselves. I mean, we failed or we learned quite a bit along the way. Yeah. But when it comes to this type of development, you have to really partner with your clients.
This is sort of a co-development?
To a degree, certainly, yes. So we always took control of the machine learning elements. Yeah. We developed the sensors ourselves. We basically took care of the product, but how we shaped the product was very much based on conversations with early adopters, for sure.
So you're an entrepreneur. You've started several organizations. You have an idea. And you don't have a background in machine learning. By now, I think you understand quite a lot about it, but at this moment, maybe not quite as much. How do you make sure this is realistic? How do you make sure that so that you have enough trust in what you want to do is possible? What was the way that you went about that?
I think that's an essential part of the culture we've created as a company, where I was most of the time spreading the gospel, if you will, talking to customers, talking to potential partners, talking to academia about what we aim to do and how we would go about it. bringing back ideas from those conversations and from, basically things that I came up with myself. And talking to our own team, my co-founder Gerber, I called him the Dream Crusher, right? I would bring him an idea, and he would say no, a lot, which is good, right? Because you are constrained to a large degree by resources. What can you execute on? What can you not execute on? So I think we created a culture where the best ideas win. My job was to generate a lot of ideas. I did that based on my 10, 15 years experience in sort of IT data environments as a non-techie, but I had enough, let's say, technical baggage to have at least understand which topics are worth discussing. But the devil is always in the details. So and we solved that by creating this culture where the best ideas win.
So you clearly have strong affinity with the contents of the domain, but I assume there are also parts of the implementation where you had to rely on others within the organization, within your own organization, and their expectations of whether they would meet certain outcomes or not.
100%.
Yeah. How did you manage that?
Well, I suppose it's the reality is we were lucky a few times. To be fair. So I think the first time we had very high expectations and we failed miserably was when we deployed 300 sensors at Heineken. Because in our lab situation, and for reference, our lab was a motor with a pump in our office space where we basically introduced failures on anywhere on the drivetrain. Yeah. And we could see in our data that we saw a meaningful change, and that change in the data repeated itself. So we thought, okay, we now have what we call a fingerprint for cavitation or for bearing faults.
Something reusable.
Yeah. Reusable, indeed, yeah. What we found then in the real world is that, and only after painstakingly installing 300 sensors, is that if you do that based on current data alone, you miss an essential component, which is the speed at which the motor operates.
Yeah, that other variable. Yeah,
excuse me?
Yeah, that other variable. Yeah,
exactly. Yeah. And so that was a difficult moment because an entire team of, at the time, I think 12, 13 people had been working towards this moment. We all intuitively felt like this is sort of, or we were hoping for a eureka moment, right? We'd proven it in the lab and now it's working in the field. So when that didn't happen, we had to, just as much as we had to explain to our client how we would make it right, we also had to make the tough decision, right? Do we go on, yes or no? Because developing a sensor system from the ground up is about 100K at the very minimum in euros, and took about a year to complete. So we essentially had to do that all over again. And it has been very challenging to keep the team engaged throughout. But I think we did benefit and still benefit from the potential of creating essentially networks of smart connected machines that are in some ways the data fabric for smart factories of the future.
Yeah. So and how did, in this case, Heineken react? Because you were very hopeful, great preparations, and then it failed spectacularly, to quote you. How do you then deal with your client in this case?
Well, we were able to explain exactly what went wrong. And because we always spoke in terms of this is what we're going to do, this is what we expect the result will be and why we have that expectation, we simply went back to them and told them we were wrong, apologies. And to their credit, they accepted a retest a few months later when we had a new version.
And that worked.
It did.
Nice. Yeah. That's a good story. And was there a moment where you thought, I'm not so sure whether this will ever work?
Many times.
Yes.
To be fair. Well, I mean, hardware is hard, is what they say in sort of technology development, right? And it's expensive. It takes a lot of time. And there were quite a few moments where the sort of family life catches up with the long nights and days.
Sure,
So,
yeah.
but across the board, across the time, it's been a real joy working with very motivated, very talented individuals, both in our team and on the client side. I think by and large, we've always managed to show progress. I think we benefited from the fact that we are, we're grounded in technology.
Yeah.
So it's a constant back and forth of creating hypotheses, testing them, seeing what comes out of it, and learning from them. So a failure, we kind of rebranded failures as learning opportunities to do better next time. And that's a good rhythm to be in.
Are you willing to share some? So if I today start an organization like yours, let's pretend not in your domain, what type of advice would you have when you really look at the sort of the AI part of your solution?
I think so. What we see today is that getting 80% right is fairly easy, but the last 20% is typically where you see the real benefit from a client's perspective. And what that initially we wanted to sell to as much customers as possible because that showed commercial traction.
Yeah.
Commercial traction attracts capital. From a development perspective, it's wiser to focus on one or two or maybe three use cases with fewer clients because that allows you to go much deeper into their field. So I think we wanted to scale up too soon. That's what I would do differently next time for sure. I think another element is that if you're developing technology, if you develop machine learning algorithms or any other algorithms for that matter, the direction is towards autonomy, or at the very least, more automation tends to be better.
Yes.
And what we found is that introducing an engineer, providing this as a service, essentially enables us to initially to say, okay, the algorithms are weak in these domains, so we put a human in the loop to sort of, help the algorithms become better. And before we send out an alert to a client, we'll have somebody review it, whether the AI is hallucinating or at least or seeing things that are simply not there.
Mm-hmm.
So what it turned out to be is that when you look at the NPS or the Net Promoter Scores, the client feedback we regularly obtain, that human in the loop, that service element is often in the top 3 of things they appreciate the most about the technology. And so developing technology with the view that, on the verge of sounding like a robot, but humans and machines are better together, right?
Yeah.
Where you ask them to work together rather than the one replacing the other. I think we would have benefited from accepting that truism earlier on.
It's interesting because I think an analogy exists in software development where that's also seems to be the case, that using LLMs to develop software systems or to make change on software systems is great, but it's often much, much better with a human in the loop orchestrating. I don't think NPSs are scored in this particular situation, but I see an analogy, which is nice. Is that talking about, so where are you today? If you look at your it's a last platform, SAM4, I think it's called.
Yeah.
What steps have you made since?
Today we are, and I can proudly say, the by far the biggest player in our niche, right, in electrical signature analysis. To be fair, it's still very much a niche, right? Mm-hmm. We are about 100 people, and we're the biggest in the field, which shows a lot of upside potential, if I call it like that. I think so. What we continue to do is to create more and better insights from data. So that is improving the algorithms, lowering cost, better, cheaper, faster, so to speak. That's one element which is almost a continuous cycle. The other thing is that we're moving from individual machines more to a system approach. For instance, if you look at, we have a very rich energy data coming from the electrical signal.
Yeah.
So we can show where and how you can save energy on an individual pump. But that pump is typically part of a bigger system. And so if you start to look at things like performance and energy efficiency on a system level, you get a whole new sort of paradigm to look at your machines and further increasing the insights that we provide and basically giving maintenance teams and operators more choice about what to do next.
So in the AI Boardroom Gap report that we recently published, it says that only 1.5% of systems in production are AI technology. So that implies that there are many more systems that organizations work on, but don't end up in actual production. Why do you think that is?
I can only assume that a part of it is because the system doesn't solve a problem in a trustworthy way, right? I mean, what we've seen in our own work is that what works in the laboratory doesn't automatically scale into the real world, and so I can assume that if you don't set up those AI-powered systems with the end goal in mind, you run into trouble. What I observe is, for instance, that the guardrails aren't defined properly, right? And to me, a guardrail in an AI system is what it can do and should do, but also what it shouldn't do, right? You don't want to, as soon as an AI starts to make choices on your behalf, you better make sure that those choices fall within acceptable limits. So that's where you see that typically the environment in which it is been developed is almost like a laboratory setting where unintended consequences are not a real problem, where potentially everything that should be known to make a proper decision is exposed to the system. But when you then scale it up to wider deployments, that doesn't work. So my hunch is that a lack of trust in a diversity of environments that you need to deploy it in is the basis of that.
You bring up this notion of guardrails, which is very, very interesting. Do you have examples of guardrails that play a central role in your solutions?
Yeah, one very clear guardrail is that we advise our clients what to do next, but we don't take action. And that is for the very simple reason that the map is not the territory, right? We create insights into how a machine behaves, often in the context of the system, but we don't know everything that is meaningful, or algorithms do not have access to everything that is meaningful. An example could, for instance, be that we see that a pump is producing a flow at a much higher rate than is energy efficient. But if the reason for that higher flow is because, for instance, safety precautions, then essentially if we would tell our clients you can tone it down a little bit or power it down a little bit, then the client will assess that it will increase the risk of fire. It's better, we hope that they choose safety over energy efficiency in such a case.
But in a way, this is a function of not having a very complete model yet. And so if that map becomes a more accurate description of the territory, so if you become closer to knowing these contextual things, then probably that guardrail becomes less interesting. Is that a future for Samotics that is something you want to work at? Or would you say no? It's better to really focus on being really good within that very confined model that we work in.
No, I think the general direction of industrial automation, including our own work, is towards autonomy. Whether that is reasonable or even achievable results in all domains, I don't think so. And in my view, it serves more as a useful direction than a goal in and of itself. I think the goal is to create better business outcomes. And typically that is where you empower people to make better choices. And the way I think about it is that as we automate more and more, the number of decisions that an automated system will make becomes higher. And so the choices that an engineer makes are usually more expensive in a very real way. But I like to think of those choices sort of as the last mile, right? Or the cherry on the cake or the icing on the cake.
Yes, yeah.
And so today and yesterday, but also tomorrow, what you see is that last mile is where the real value comes. That's the human decision making that creates the best outcomes. So through automation, typically powered by machine learning or by AI, I think that last mile is becoming shorter, but it is more steep. So there's fewer choices to be made, but they are more valuable. Or because of more insights through analytics, you increase decision space. So you give more options to choose from. But I think in all conceivable scenarios, certainly for the next, let's say, 5 to 10 years, the goal is not to create fully autonomous systems. The goal is to create better business outcomes by making sure that you provide more options and that you can trust the system to a higher degree and really make it part of workflows.
So even at scale, you still see the human in the loop?
Yes.
Yes? Okay. So when it comes to security, AI systems have changed a lot. I think the domain in which you work, in which your solutions work, tends to be slightly conservative about data in there. Factories used to be really closed, and now slowly automation and these platforms are poking little holes in the factory walls. How do you deal with these stringent security requirements and the trust that requires?
From a security perspective, we benefit from the fact that we capture a very simple data and that only after analytics it becomes valuable and insightful, right? So that it takes away some of the rough edges, right? We're not peering into the control systems that could potentially derail a factory. So that's not happening. What that does not mean is that we should not take security with the highest regard within our systems, right? It's always been architected with security in mind for the simple reason that it's probably the second or third question that's coming after, okay, so what is the value that we deliver?
Yeah.
And so what I see in our clients' domains, not just how we work with them, but generally speaking, when it comes to integrating technology into their stack, is that there's a balance to be found between the benefits of a technology, the risks that you inherently take when you expose your data outside of your own walls, and the cost to mitigate of those risks. Where that balance lies, I think, is very different from client to client. But I do sense that it is in the boardroom there is more acknowledgement, so to speak, that the risk is very real. But if you allow that risk to close down every data source to the outside world that could turn that data into value, is also not a solution.
That's a loss.
Yeah.
And how do you manage this internally as your solutions are getting more complex and larger? You're not immediately involved with development, of course, but how do you make sure that you can really rely on the continued security of the solutions that you have? Is that something that you have measured outside? Is there tooling inside that you use for that? We're certified, so ISO 27001, which repeats every year. Yep. Also, the company is certified based on ISO 9001, so we're a well-managed company. Yeah. And we have pen tests every now and then that go beyond what 27001 demands and simply say, are we still secure, right? 27001 looks at the measures we've implemented, and then verifying whether we are aligning with our own internal rules is creates a system that is secure. So if there's one thing that you think business leaders should take away from this conversation, one thing that you think people should really remember, what would it be?
I would say start with the problem in mind. Start with what you want to achieve. I think that we're in a stage where technology will not be the main blocker to better business outcomes. I think technology can solve most problems that are worth solving. I also think that it's not just a technology problem. What really makes a difference in day-to-day operations is trust. So trust that your data is true, for lack of a better word, that it's valid, that it's accurate. Trust that your systems, whether that's machine learning based or otherwise, can turn that data into insights that are useful and accurate. And also trust that the teams will use that to their advantage. And typically, if you deploy any type of software or any type of system in your organization and it doesn't scale, it's probably because it's not very helpful on a day-to-day basis, or that people don't trust it, or a combination of those. So start with the end goal in mind, not with the technology, and make sure that you have a high degree of trust that the system will deliver useful, valuable outcomes in all situations.
Thanks, Simon. It's been an education. This was very interesting. In the show notes, you can find a link to the AI Boardroom Gap report that we've published. We have monthly episodes of the podcast. You can subscribe to our channel, and you can also see the other podcasts that we've made in the past. Thank you very much, and see you next time.